Everybody ready? Take notes? You got your notebook out, ready in front of you? All right, let's do this. Shouldn't take too long. Should be pretty simple. It's called the distributive property. We know what distributive property is. So let's write it down with just some letters, and we'll do a couple examples. Actually, 3 examples. All right, everybody up here? Everybody's up here? Thank you. I can tell I'll be moving some seats pretty soon already. AB plus AC. You remember distributive property, don't you? You had Algebra 2 last year, right? You had to do distributive property in Algebra 2. Absolutely, 100%. Correct? No? Nobody's talking to me? What's going on? You guys are dead. Come on. Help me out. Remember this? If this is being multiplied by 2 things that are being added in the parentheses, then you take that A, you multiply it by the B, then you take the A and you multiply it by the C. That's how we get AB plus AC. So this times B plus this times C. What if it was B minus C? What would it be? AB, what? Minus, what? AC. Don't forget that A on the outside. It's being multiplied by everything in that parentheses. Every once in a while, I'll have a student just go AB minus C. Is that what it is? No, it's AB minus what? AC, because the A is being multiplied by both of those things right there. You could have something like this. Sometimes the number will be on the right-hand side. Most of the time it's not, but every once in a while, like today in my Algebra 2 class, we did a problem where the number was on the outside or on to the right. If you wanted to, you could just put the C on the left if you like that better and just do that. That's the same exact thing. Would you agree? Yep. So you could go what? What would this be? AC. Yeah, you can go AC or CA. Doesn't make any difference. If it was me, I'd probably write AC just because I like in an alphabetical order, right? That's the only reason. If you put CA, it's just as right, all right? It's not any more right or wrong putting AC than it would be CA. Plus, what? You can go CB or you could go what? BC, all right? So that's what that would look like. You could also, if you wanted, just keep it on the right, not put it on the left. You could have taken it and done this and then done this. It's the same thing, isn't it? C times A or AC, there it is. C times B or BC, there it is. So you get the same thing. It doesn't matter if it's on the left or the right. Is this familiar to you? Okay, little nod would be nice. You don't have to say anything. Yes? BC and what? Yeah. Yeah, B times C is the exact same thing as C times B. All right? And that's one of our properties, isn't it? Isn't that the commutative property? I think it is. Which one is it? Is it commutative? Yeah, because look, let me show you an example. 2 times 3, is that the same as 3 times 2? Yeah, absolutely. 6 equals 6, right? So they got to be the same. But does it matter? That's my point right here. Does it matter if you write BC or CB? No. But my preference, all right, you don't have to do this, but my preference is probably to write it as BC just because it's an alphabetical order, it just looks a little nicer. But that's the only thing for that. Okay, enough of that. Let's do a couple examples. Wow, the first one's super easy. So this is example 13. So if you look in the book, it's example 13. And this is part A. We're going to do A, B, and C. So it's 2 parentheses x plus 3. Distributive property doesn't get much more basic than this thing right here. Okay, you can't really get a whole lot easier. So what is that 2 doing to the stuff in the parentheses? Being multiplied. So I got to take the 2, multiply it by the x, put the plus sign down, and then take the 2 and multiply it by the 3. So what's that going to be? 2 times x. It's just 2x, yeah. Now, on this one, you could write x2, but nobody ever does that, okay? We always put the number out in front of the letter, right? So AB, BA, that doesn't make any difference, but you always want to put the number out in front of the x, okay? Plus, what? 2 times 3. Can we just do that in our head? What's 2 times 3? It's 6. And there it is. You've done a distributive property. Super easy. All right, the next one's not much more difficult. Remember how we put that C on the right-hand side earlier, just a minute ago? We're going to kind of do the same thing here. So this time they go, okay, they change this up a little bit, and they put the X right there. So how would you do this? There's actually 2 ways you could do this. One way, I wouldn't even use distributive property. If you just had to figure it out what that is, and they just told you to, I don't know what they would tell you, simplify maybe. Maybe that's what they say. I don't even write it down, what they tell you to do. But you could just do the stuff in the parentheses. Because right here, can you add x plus 3? Can you combine them together? No, because you don't know what x is. But look at this. You got a 3 plus 5. You do know what that is. What's that? That's just an 8. So what is that? 8x. That's the easiest way to do it. Would you agree? Yeah, pretty simple. Or you could, I'm just going to show you that it comes out to be the same thing. All right, and I think that's why they did this. If you wanted the x out in front, you could do that. If you didn't want it on the right-hand side, again, doesn't matter. You could keep it on the right if you wanted to. I don't know, it just looks a little nicer, right, going from left to right. Wouldn't you agree? So you could do this. You could go x times 3. What's x times 3? 3x. Put the plus, and then do the x times what? 5. What's x times 5? It's 5x. What's 3x plus 5x? 8x. Isn't that exactly what we got earlier? Yeah. Now, that's a little bit longer to do it that way, wouldn't you agree? And so I would do it the first way we did. I would just say, oh, 3 plus 5 is 8, times x is 8x. Bang, you're done. All right, but it just shows you that the distributive property does work. You can't add them together, right, because they're not like terms. Good question. This has an x. This does not have an x. I can't add the 2 together. Everybody good? Okay. One more. Oh, here we go. Now we're really going to do some distributive property. Again, this is an Algebra 1 topic, but I'm going to show you how to do it. If you didn't learn it before, if you forget it, you just don't remember it, then I'll show you how to do it. Now, look, this is a little different because, look, I got 2 things multiplied by 2 things. Over here, what do we have? We just had 1 thing multiplied by what? 2 things. Okay? So that made it kind of easy. This one's a little trickier. Let's see if you remember how to do this. And there's a special word that we use that's not really a word. It stands for, like the first letters make a word, right, of this little phrase. So what are we going to do? We're going to take, since there's 2 things here, I want to take both of these things and multiply them by both of these things. Does that make sense? So I'm going to take the x first, and then I'm going to multiply it by that. Then I'm going to take the x and multiply it by what? The 3. So that's kind of like what we did earlier, right? But now we got an extra thing in there. We got that plus 2. We didn't have that before. So what do you think I'm going to do with that? I'm going to take the 2 and multiply it by the first one. And then I'm going to take that 2 and multiply it by this one right here. So that's the order that we're going to multiply these things in. So the x times the x, the very first one that we did, that one right there, we call that the first. And then, do you see how the x is on the outside and the 3 is on the outside? So what do you think we're going to call that? Outside. And then we did these 2, didn't we? Those are in between, right? They're in the inside of the whole thing. So I call these 2 the inside. You know where we're going with this? Guys are so quiet. All right. You don't know where we're going with this? Or you do? Or are you just not saying anything? Gianna, did you say something? What is it? Okay, yeah, this is the last. So I think you're on to me now, right? So this would be the last. See, the first two would be the first ones, the 2 and the 3 are the last ones, and so we'll call this the last. What word do we have if you take all the first letters? FOIL. You know that. You've heard that a million times, haven't you? The FOIL method. Danae, you've never heard the word FOIL method? You're a senior at Red Lion, and you've never heard the FOIL method? Well, my goodness. Well, now you have. Okay, so you can't leave here, Red Lion, without saying you don't know the FOIL method. So that's what we call it. We call it the FOIL method. All right, but those letters stand for something. First, outside, inside, last. Everybody got it? That tells you the order that you multiply these things through. So let's do the first. What's the first? It's the x times the x. Would you agree? Those are the first. So what is that? X times x, which is, I'll tell you what, I'm going to write it down like this. X times x. It's not 2x. You're multiplying together. What is it? X squared. Very good. All right, and then you take that x and you multiply it by the 3. That's the outside terms. So what's x times 3? 3x. What's the sign? Is it positive or negative? Positive. So you put a plus. 3x. Now we do the inside. It's these two right here. It's a positive 2 times a positive x, which is positive 2x. So we put a plus sign. Then we do the last two terms. This 2 and this 3. We multiply them together. So it's positive 2 times positive 3, which is positive 6. Let's finish it up. What's x times x? X squared. And then you add some like terms. So you got to add these two together. What's 3x plus 2x? Plus 5x. And then plus what? 6. And there you go. That's your answer to this problem right here. So if I multiply those two together, that's what my answer is. You don't remember doing this in algebra? This should be an Algebra 1 topic. You had Algebra 2 last year, and you didn't do FOIL method? Oh, my goodness. Well, now you have, so I feel better about it. Don't you feel better? You can't leave high school without knowing FOIL method, all right? But there it is. And that's your answer. You don't know what x is. You're not solving for x or anything like that. Later on, we'll set this equal to 0 and we'll solve for x. But not today, all right? All we're doing is just doing the FOIL method. All right, that scares me a little bit that you guys didn't know this. I thought this would just be like, oh yeah, that's easy. Why are we doing this? This is too simple. But that's why we're here, all right? So that's why I'm teaching this stuff. I can't leave it at that. We got it. Look at some more stuff. So let's, let me get, now you won't be able to see this on the YouTubes, but let me get that book out. So you're going to do page 16. So let's go to page 16. And let me scroll down until I get to page 16. There we go. So that's what we're doing right there. And I'm going to have you do numbers 87 to 97. I should have you do them all, up to 98, really. It's not that many. It's 12 problems. I'll stick with what I said. Okay, I'll stick with the odds. 87 you should be able to do. 89 you should be able to do. 91, what's the only difference between 91 and those other two? You got a fraction. This distributive property is still the same. So let's do, tell you what, I don't want to take away from the fun of you doing the odd problem. So let's do an even one, all right? So I can just demonstrate it. So let's do the first one. Let's do 94. X plus 5, x plus 1. So let's do it again. After I finish this, we'll write it down.
What page is it?
After I finish this, we'll write it down. Did I say plus 5 plus 1?
You said to go to page anything, right?
I'm asking you about this. X plus 5, x plus 1. That's what I'm asking about. Okay. Yes, that is what we have to do. So I will give you 1 minute. 1 minute. Ready? Go. Work on it yourself. All right, I didn't set a timer, but is that about a minute? Did you get an answer? Okay. So here's how I would do it. Here's how I would do this. It's first, outside, inside, last, which is what method? The FOIL method, okay? So here we go. I'm going to put it equals the first. And if you want to put those lines there, feel free. You know what I'm doing with this, right? I'm just showing you which ones are being multiplied together. So it's the x times the x. What's x times x? X squared. Yeah, you get used to that pretty quick. And then the outside. Which ones are the outside? These two right there, okay? So it's x times 1. What's x times 1 or 1 times x? It's just x. So I put plus x. Let's do the inside. Those two are the inside. So it's positive 5 times positive x, which is plus 5x. Make sure you put the pluses there. Now, sometimes you'll have some minus there. I'll make one up after this one with a minus in there just to show you. And then what do we have here? Plus 5 plus 1, that would be the last. What is 5 times 1? 5. We're not done because of this. What do we call those? Like terms. So we got to add the like terms. So I've got x squared plus, what's the number out in front of this x? It's a 1. It's always a 1 if it's not there, okay? So it's a 1x plus 5x, which is 6x plus 5. And that's your answer. Did you guys get that? Okay. Let's do another one. I'm going to make one up. Let's go x plus 3 times x minus 2. All right, ready? Go. All right, time's up. Ready? First, outside, inside, last. Here we go. I'm not going to draw the lines this time. Is that all right? Because eventually, you don't want to draw these things every single time you do this. But if it helps you, feel free to do it. All right? You can do it, but I'm not going to here. So first, x times x, x squared. Outside, it's 1x times negative 2, which is a what? Negative 2x, or a minus 2x. Inside, these two right here, both positive, so it's a plus 3x. Then the last, these two right here, positive 3 times negative 2 is negative 6. Okay, got to add the like terms. Don't forget to do that, so don't leave it like this. Make sure you always add your like terms. So you got an x squared, you got a negative 2x plus 3x. What's negative 2 plus 3? Positive 1. Positive 1 what? X. You can put the 1 in front of it. You don't need to. I'm not going to put it there. And then you just put minus x, and you're done. And that's how you do that. Let's do one more for fun, all right? Isn't this fun? Like, sure, you're crazy. X, I don't know, minus 4 times x minus 7. All right, do that one. Again, I'll give you 30 seconds this time since we've been doing a few of these. All right, 30 seconds is up. Did you finish? All right, let's do it. First, outside, inside, last. So the first, x squared. Outside, negative 7x. Inside, negative 4x. Last, positive 28. Going a little quicker because we've seen this a couple times already. Add like terms. I've got x squared. Negative 7 minus 4 is negative 11x. So you got to put a minus sign here. If you put a plus 11x, it's wrong. You got to have the minus 11x. And then You can't do anything with that 28, so you keep it there. That is your answer. Anybody get that in 30 seconds? Okay. So that's FOIL method. Now you know. Okay. Eventually, what we're going to be doing is I'm going to be giving you this. Everybody looking up here? I got like 2 people looking. Everybody look up here. Eventually, I'm going to give you this, and I'm going to ask you to come up with that. So it's kind of like going backwards, like the backwards FOIL method. It's called factoring. Did you guys do any factoring? If you didn't do FOIL method, I have strong doubts that you ever did factoring. But we're going to do it in here. All right. I'm going to teach you what you're supposed to learn basically in Algebra 1, right? Because factoring is an Algebra 1 topic. I'm not saying this to make you feel bad or anything. I'm just saying we got a lot of catching up to do, all right? And that's what this class is for, to catch you up on this stuff. Because if you go to a 4-year college, whether or not you take anything math-based as a major in college, you could take interpretive dance, for all I know, and you're going to have to take some basic courses. You're going to have to take an English class, a history class, a math class, and that's what I'm trying to prepare you for. This class is not for math majors. Okay, if you want to be a math major, you should have been in Algebra 2, pre-calc, calc, and all that kind of stuff. But this is to get you through your first prerequisite math class that you have to take when you go to college, if you go to a 4-year college, because you're going to have to take a math class. And you're going to have to know this stuff, all right? You're going to be in I was going to say you're going to be in a class full of kids that probably already know this, but I bet you anything, you go to your first, basic math class, there's going to be a lot of kids in there that don't know much at all, and you're going to be telling them how to do some of these problems, because that happens all the time. I get kids all the time coming back to me, Mr. Hamrick, you wouldn't believe, I went to this class, these kids didn't know how to do this, that, and the other thing, and I was showing them all how to do it. I was like, that's awesome, I'm proud of you. And I was. I mean, that's what I'm trying to do. I'm trying to prepare you so that you can do that kind of stuff, all right? So I'm doing you a favor. This is not you against me. I'm trying to help you out here. I really am. Everybody good? Okay. You asked what the homework was. It is. Did I write it down earlier? No, I'll write it down now. So we're going to call it C. It's the third of R1, the third homework that you've done with R1. And we're going to call it page 16, numbers 87 to 97. And against my better judgment, I'm only making you do the odds. I think I'm taking it a little easy on you, but there you go. Everybody got that? Okay, that's due tomorrow, so get it done tonight. When do we get out of here? 15 after? So you got 15 minutes. I bet you, it's only 6 problems. I bet you could do those 6 problems in the 15 minutes that we have. So let's start working on it right now. Try to get it finished. Then you don't have any homework. That's the best, isn't it? When you go home, you're like, no homework. All right.